Hello guys, in this video we're going to look at finding indefinite integrals using infinitesimals. Oh my gosh. Hello guys, in this video we're going to look at finding indefinite integrals using infinitesimals. What is an indefinite integral? In the previous video we derived an equation to represent the area under a curve between two points A and B. We call this the definite integral. An indefinite integral is a form of the definite integral where a is 0 and b is our x value. We integrate from 0 to an arbitrary x value. So the reason it's called indefinite is because the answer is not just going to be a number. It's not going to just be like 26 is the answer. The answer is going to be in the form of x. So it's going to be something like 24x plus 3 or something like that. Hello guys, in this video we're going to look at finding indefinite integrals using infinitesimals. What is an indefinite integral? In the previous video we derived an equation to represent the area under a curve between points A and B, and we called this the definite integral. An indefinite integral is a form of the definite integral where A is 0 and b is our x value. We integrate from 0 to an arbitrary x value. So the reason it's called indefinite is because your answer is not going to be like, it's not going to be definite. It's not going to be like 24, 36. You're not just going to get a number. You're going to get something in the terms of x. You're going to get a function out of this function. So you might get something like 24x squared plus 3x. So you're not going to get a definite answer out of this. Indefinite integrals are usually written with the same notation except that a and b are left off. So here it was the form we used before, so I put 0 for a and x for b. But since these are always going to be true for any indefinite integral, I usually just leave them off. So it's just this little squiggle. We can use our original definite integral formula by simply replacing a with 0 and b with x. So this is the same formula we used before. I just plugged in b as x and 0 for where the a's are, and so the a here becomes 0, a here becomes 0. We can simplify this down so these zeros can go away, and the x minus 0 just becomes x. So now we've derived our formula for our indefinite integral. So it's epsilon over 2, the summation from 1 to x over epsilon, the function evaluated at epsilon I plus the function evaluated at epsilon I minus epsilon. Let us use this equation we have derived to evaluate the indefinite integral of f of x when f of x equals 2x plus 4. So f of x 2x plus 4, and we're going to use this formula we just got. So the first thing we do is we say, okay, we're taking the indefinite integral of 2x plus 4 and we just plug it in. So this function, the first function becomes 2, and we replace the x with epsilon I plus 4, and then this here is another 2x plus 4, but we replace the x with epsilon I minus epsilon, and then we just multiply it out. So like 2 epsilon I just becomes 2 epsilon I, and then here we just added them, just did the addition, so 4 plus 4 became 8. And then what I've done is since these two right here are constant, I pulled them out. Because if you're adding something, a constant, every time, n amount of times, that's the same thing as just multiplying those constants by n. And n in this case is x over epsilon. So I've just pulled these two constants out of the summation and then multiplied them by x over epsilon. And then what I did was I just multiplied them out. So I actually multiplied those two constants by x over epsilon, and that's what I got. And then here we have 4 epsilon I. The 4 epsilon is a constant, and we can pull that out of the summation just by multiplying it by the summation. And anytime you have a summation I, that's the same thing as n squared plus n over 2, or in this case, n is x over epsilon, so x over epsilon squared plus x over epsilon over 2, and then I just did the squaring. So here, what I've done here is I've taken 4 epsilon and I've multiplied it into it. So the 4 gets cancels out the 2 on the bottom. However, there's 2 left over, so these both get 2 multiplied by them. And the epsilon cancels out one of these epsilons. So we end up with just 2x squared over epsilon plus 2x. And then since these both have like denominators, we can connect them. And then what I do is I multiply epsilon over 2 into both of these. So we this epsilon cancels out this epsilon, and this 2 cancels out this 2. This 2 makes that become a 4, and cancels out this 2, but adds an epsilon here. So we end up with x squared plus 4x minus epsilon x plus epsilon x. So those two cancel, and we just end up with x squared plus 4x. So is this the answer? Is the indefinite integral of 2x plus 4 equal to x squared plus 4x? The derivative equation. Recall the derivative equation. Let us use this to find the derivative of the indefinite integral we just found. So we just got 2x plus 4. Now let's find the derivative of this. I'm not going to rediscuss all this again. This was 2 videos ago if you need to figure out what this means again. So we find the derivative of this. I just plug it into this formula and do the math, and we end up with 2x plus 4. So the indefinite integral is the antiderivative. This means that the indefinite integral of the derivative of the function is similar to that function. So I had x squared plus 4, then I found the derivative of it, and I got 2x plus 4. But when I found the indefinite integral of 2x plus 4, I got x squared plus 4. So I got the same function back. If I find the indefinite integral of the derivative, I get the original function. When finding the derivative of a function, constants are always dropped out. So here I have 3 functions, x squared plus 4x plus 3, the same thing plus 24, same thing plus 126. In this example, the derivatives of all 3 of these functions are equal because only their constants differ. So the only thing different in here are their constants, and these are always dropped out when you find the derivative anyways. So the derivative of one, the first function equals the second equals the third, they all equal 2x plus 4. Since the constants can be anything, it is impossible to know what it is when simply given the derivative of a function. This means after integrating, a plus c term should be added to make it clear that there is an unknown constant. So in this example, as you can see, when I took the integral of this, the derivative of a function, when I took 2x plus 4 and I take the derivative of that, I get x squared plus 4x, but I don't know if it's this x squared plus 4x, this x squared plus 4x, this one. I can't tell because the constant could be anything since it was dropped out when finding the derivative. So you add a plus c just to represent that there is an unknown constant there. So this is the actual answer. So when you find the antiderivative or the indefinite integral, which essentially mean the same thing, the indefinite integral of 2x plus 4, we get x squared plus 4x, but we add a c to it. So x squared plus 4x plus z is the answer.